Hi, I'm Charly Wargnier. I'm a developer advocate here for Streamlit at Snowflake. I wear many hats. First of all, I get the community excited about new features and new applications. I also fix bugs and I help developers be successful with Streamlit. I actively participate in the product roadmap to make Streamlit a better product overall. I also build apps, a lot of them, use cases, demos, templates for our clients and the community. And lastly, I also lead the Creators Program, which is basically a bunch of amazing people having done great apps or having tremendously helped the community. Welcome to my talk, How to Create a Zero-Shot Learning Text Classifier using Streamlit and HuggingFace. What's the agenda today? First of all, I'll show you the cool stuff we'll be building. Then I'll give you some context about Zero-Shot Learning, HuggingFace, and of course, Streamlit. And then we'll get cracking. I'll show you how to create a virtual environment for your application. I'll show you how to install Streamlit and all the libraries we need for our app to work. And then I'll show you how to get your HuggingFace API token. Then it'll be time for us to dive into the code. And lastly, I'll show you how to deploy your application for free on Streamlit Community Cloud. Here's a simple yet mighty app we'll be building today. So it's a zero-shot learning text classifier using HuggingFace and Streamlit. And as you can see, it's pretty straightforward. You can set up your predictive labels on the fly. You can type them, and then you can add your key phrases to classify. That could be anything. You can classify per sentiment. You can classify per user intent. You press submit, and magic, you'll get all your key phrases classified with the predictive labels and the classification scores in the table at the bottom. Well, you can even download your results to CSV if you want to use them somewhere else. So I'll put the links in the presentation. At the top, you've got the link to the repo. You also have a QR code for that if you wanted to download this repo on your local machine and play with the app yourself. You also have a link to the application at the bottom. So what is zero-shot learning? To make it quite simple, traditional machine learning methods can detect, recognize patterns in data, in objects, yet you do need to train your samples. It does take some time. With zero-shot learning algorithm, there's no training needed. So you can actually, with a pre-trained model, get your predicted results on the fly. To do zero-shot learning, we can rely on several technologies. But today we'll use the HuggingFace API Inference. Think of it as a plug-and-play machine learning via simple API calls. If you want to integrate NLP, or natural language processing, computer vision, or audio processing algorithm into your applications, I highly recommend you to have a look at the HuggingFace API Inference. To make those label predictions, we'll rely on the pre-trained machine learning model distillbart. And again, that's going to be a simple API call that we'll be using. I'll describe the code in more details later on. To display the data and the results, we need a front end, we need an interface. And for this, we'll rely on Streamlit. For the very few of you who don't know what Streamlit is, this is an open source framework which helps you make any kind of data apps very, very simply and quickly. So it's not just limited to machine learning. That could be any data app. And basically, Streamlit is built with Python. So it's literally just a Python script, which means that you don't need to have any HTML knowledge, CSS knowledge, or JavaScript. There's absolutely no front-end experience needed. If you've got a bit of Python under your belt, you can design apps in a few minutes. Lastly, you can also deploy your apps for free and in minutes on the free service Streamlit Community Cloud. I'll show you how to do it later on. So let's get started. What do we need? First of all, we need Python. We recommend to download Python 3.9 or above. We also need an IDE to be able to code. We'll use VS Code in this tutorial. You've got the link here to download it. You can use any IDE if you wish to use PyCharm or Spider or anything else. That's perfectly doable. With regards to Python libraries, we'll certainly need to download Streamlit, requests for the API calls, pandas to manipulate and display tabular data in our tables, and also a Streamlit component called Streamlit tags, which we'll use for dynamic tagging. And we also need to create a virtual environment. Actually, we don't need to. You can certainly create your application on your local machine in a folder, but this is highly recommended. This is really best practice when you code. Basically, what it does is it will create a bubble in isolation when you have your application, and all your libraries and dependencies again in isolation, which means that you will not have any conflicts with any other apps you'll be creating on your machine. So it prevents bugs and errors. So to create a virtual environment, open your terminal and type conda create -n, the name of your virtual environment. So in this instance, we're going to call it 0shot, and the Python runtime or version. So we'll use Python 3.9. Once that's done, you need to activate it. And you just need to type conda activate, and again, the name of your virtual environment, 0shot. Once this is activated, you need to install your libraries. So we'll install Streamlit via pip install Streamlit, and then we'll install the other libraries. So you can chain them in one single line: pip install requests, pandas, numpy, and Streamlit tags. Now it's time to dive into the code. So before we do so, let's have a quick look at the app structure. Basically, this app structure is pretty much the same as any Streamlit app. You'll have your main file, which is a Python file, which we tend to call streamlit_app.py as best practice. We'll have a folder called .streamlit, where you'll have all your settings and configuration files. We'll have a config.toml, which stores all the configurations and all the settings, but also a secrets.toml file, which will store your secrets data. So that could be your API key, like in this tutorial. That could also be your database credentials or anything that you don't want to show to the users. You will also have an images folder where you store all your images, a README file for the GitHub. So that's this kind of informative page that you have on the GitHub repo. And lastly, you've got a requirements.txt file, which contains all the libraries you need for your application to work in a deployed environment. Next, we need to get our HuggingFace API key. To do so, create a HuggingFace account at huggingface.co. Once it's created, go to Settings, Access Tokens, and then you have your API inference key at the very top that you can copy and paste into your application. So you will paste the key into the secrets.toml file. A quick look at the config.toml. This is where you store all your settings and configurations. We'll keep it very simple and light for this tutorial. We've only pasted the HEX code of the Snowflake blue, which will be coloring our application. Look at the requirements.txt. Here we're listing the libraries we need for the application to work in a deployed environment. We'll use Streamlit and the component Streamlit tags. So here we are. We have our Python file, streamlit_app.py, and we want to launch Streamlit locally. So to do so, you go into your IDE, you open the terminal window and type Streamlit, run, and the name of your Python file. Again, in this case, streamlit_app.py. You press enter. What it will do, and it will open a local server in your browser that will display your application locally. The magic is that every changes in the Python file will be reflected on the fly as soon as you press save. This is quite handy, right? The very first thing to do is to import the libraries into your Python file. You only import the libraries we need. We'll import Streamlit ISST, requests, pandas, numpy, and Streamlit tags. The next step is to define the layout and the title tags. So this is possible via the st.setPageConfig. The layout will be defined as centered as opposed to wide. The title will be defined and named 0shot text classifier. And the icon, which is the emoticon displayed in your browser tabs, we're going to choose a snowflake emoji. So once you're happy with this, you press save and you will instruct the local server to display the results and update the results dynamically. So you press always rerun. And as you can see here, at the very top in your browsers tab, you've got the name of the app and the emoticon. Next, we will add an image. So you can add an image via the st.image widget. You just need to paste your file path And then you can also select the width. So we're going to give it a width of 85. I'm saving, and you can see on the fly, the logo is already displayed in my application. Now we want to add a title. So to add a title to your application, you can use st.title, and we're going to call it again zero-shot text classifier. Next, we want to set up the session state. So the session state makes sure that any changes in your application, whether you want to tick a box, set up some text, press a button to save data, for example, every time, because your Streamlit application is a Python file which runs from top to bottom every time, you want to make sure that those changes do not reset your app. And so to do so, to make sure it doesn't reset, you need to set up the session state in your application. This is the line which sets it up. Next, we will create a sidebar. So basically the way it works in Streamlit to create some content, you can create some content on the main layout and also on the side, on the left-hand side. To create any widget content text in the sidebar, you simply take a widget, and between st and the widget name, you will add sidebar. So here, for example, if you want to add a piece of text, I'm going to show you quickly how it works. Test. This will be displayed in the sidebar. Next, we need to create a text input field for users to enter the API key. So let's have a look at what the code looks like. We create a variable called API key and then declare st.sidebar.textInput. We add a call to action, enter your HuggingFace API key, a tooltip. Once you created your HuggingFace account, you can get your free API token in your settings page and in the URL. And you can choose to have your text input as a password so people can't see what you're typing. And here it is. Here's on the left-hand side, our lovely text input. We also need to add the HuggingFace API inference URL, which we are declaring here with the API_URL variable. And next, we also need to create a Python dictionary to store the API headers, which we're doing here. Next, we need to add a bit more information about the app. So we can do so by adding st.sidebar.write, and then we're adding the content. So here I'm just saying app created by yours truly, Charly Wargnier, using Streamlit and HuggingFace, and the link to the zero-shot learning algorithm model. Next, we'll have a look at the main layout. So we'll start by creating a tab navigation. So it's a fairly new Streamlit feature, which allows you to add tabs to your application, which makes it more structured and ordered. And you can do so by declaring the st.tabs widget. So here we're going to create two variables, main tab and info tab, equals st.tabs and then the names of those tabs. So we can create two tabs, one called main, which will host our main interface, and another tab called info, where we'll give the users more information and resources. We'll start actually with the info tab. So to create a tab, it's super easy. You just type with space, the name of your variable. So here it's info tab, and then you'll type column, and then you'll wrap or indent your code. So here the code will be anything related to some information about Streamlit and resources. So we're going to press save and have a look at what the content looks like in the tab. So here if I press info, you see that this content is being displayed. So what is Streamlit, resources, about the documentation, cheat sheet, the book, and also more information about how to deploy your app on Streamlit Community Cloud. Next, we'll have a look at the main section of the app. So the main tab. We'll start by adding some more context, a bit of information about what the app is all about. So we'll just simply say classify key phrases on the fly with this mighty app, no training needed. Next step, we will create a form within which most of our widgets will be hosted. To do so, we can use st.form, and st.form will actually collect all the user's inputs. So all our widget values will be sent to Streamlit in one batch, which prevents the app to rerun every time and makes overall the app way faster. So let's have a look at what the code looks like. To create a form, you just simply write with space st.form, give it a name, so it's basically a key parameter. We're going to call it myform. And here we're going to start nesting our elements. So the very first element we want to put in our form is the tags, or the input where we're going to put all our tags. And this is possible via the st-tags component. As you can see here in this tutorial, we will actually make it a very simple example where we'll have 3 tags which can define any text user intent or any phrases user intent. Here we'll have 3 user intents: transactional, informational, or navigational. And in the label field, we'll have our 3 values, which will be predefined. We'll have suggestions, which are basically auto suggestions, which will be autocomplete, which will be displayed on the fly. And that's it. This is our first element. And as you can see below that, we have the text area where we can paste all the sentences or phrases. So before we have a look at the text area, we'll have a look at the max key phrases variable. So here it's just a variable that we're setting up to limit or to cap the amount of phrases that can be pasted into the text area, simply because this app is hosted online and we want to be kind with the RAM memory of the application. Before we have a look at the text area, let's have a look at the predefined key phrases that we will have in this application, hard-coded. So very simple sentences. For example, we'll have, I want to buy something, or we have a question about a product, or I want a refund through the Google Play Store. And again, we want to have a predicted labels for each of those sentences, whether it's transactional, navigational, or informational. There's a few Python calculations or data wrangling which is taking place here to make sure that the data is in the right shape. So here there's a Python list comprehension to create a string from the list of key phrases that we've declared above. And below that, we have our text area. So the text area that you can see here is created via the st.textArea widget. So we're going to create a variable called text equal st.textArea, and I have all the instructions and parameters below. So we've got the instructions, enter key phrases to classify. We've got the sample variable that contains our key phrases. We've got the height of the text area that can be set up to less or more. We've got the tooltips via the help parameter. And here, this is basically a warning message or just an information about the text area. So we want at least 2 key phrases to be pasted, so for the classifier to work. And then we've got additional lines of data wrangling or manipulation. So here, for example, we have a line which makes you sure that we can convert the text to a Python list. We need to create an empty list after that. And for each of the elements which are in the list, we will have a for loop which removes the duplicates and the empty lines. And because now we've done everything we needed to do with those 2 widgets, the label input field and the text area, we can add a submit button. So the submit button is compulsory for the form, the st form to work. Next step, we will create a set of if statements or conditional statements. This is to make sure that users have entered the correct information. So for example, if a user has pressed submit button of the form without any text, without any labels, or if there is only 1 labels, for example, in that case, the app will display a warning message. So let's have a look at those conditional statements. As you can see, they are just Python conditional statement. In this case, if not submit button, and if there is no session state, well, in that case, you can actually stop the app. There's a few others. I'm not going to go through each of them, but just to give you an idea on the first one, elif, someone presses the submit button, but there's no text. In that case, we will stop the application from running. And we will also display a warning message which says, oh, there's no key phrases to classify. And so there's a few like this. If everything has been entered correctly with all the conditions, we will continue the flow of the application. And if someone presses the submit button, it will be time for us to make the API call. So let's have a look at this API call. The API call here is a Python function. So we need to create a Python function called query. So def query, then the argument that we'll take here is the payload data. So the payload is basically the data that we want to send to Hugging Face when we make the API request. And so the construction of the query function, you've got the variable response, which is sending a post request to the Hugging Face API. And as you've seen earlier, we've created a headers variable which constructs our API call to Hugging Face servers. And as an argument here, we've got the payload. It will return the API output in a JSON form. We also need to create a Python list, which will actually store all the outputs of the API call. So we'll do it this way, list for API output variable equal empty lists. So next step is to create a for loop, which will iterate through each key phrase. Basically, an API call to a Hugging Face service will be made for each key phrase. We also need to construct our payload. The payload here is comprised of the key phrase, the labels, the predictive labels we want to compare against, and the wait for model parameter, which we're going to set to true just to avoid timeouts if we have lots of data to process. Here's our for loop. For row in line list, we'll have our function, the query, which will have the payload as an argument. And this is our payload. Once that's done, we want to append all the outputs from the API call to a list, which is basically the list that we've created earlier. And to append any elements in the list or any sets of results to a list, you will just call list for API output.append, parentheses, and then the output of the API, so API JSON output. Once that's done, we will convert the list to a data frame. We can do so by creating a variable called df equals pd.dataframe.fromDict, parentheses, and then we have our list for API output. And next we have to validate the success of the operation. If everything has worked properly, we have a call out called stSuccess and a bits of text, a call to action saying, oh, check the results. Now let's have a look whether this has worked. I'm going to display the data frame by typing st.write. And as you can see here, yay, it's working. It's still in a bit of a messy state where you've got the labels are still a bit messy. You've got the index is not right. You've got the labels, you've got all the labels, the best one and also the other ones which we want to remove. The scores are in a decimal, very lengthy form, which we want to fix as well. So we still got a bit of work to do. So let's go back to our code. Next step is to rename some columns. Here we'll rename the column sequence to key phrase. Here we go, it's key phrase now. And then we have to do some more magic. We'll select the first element of the labels output. And again, the first element of the classification scores lists. So we only display the most accurate. There's one thing we need to do though, as you can see, the index, it starts at 0, which is the default Python indexing rules. We want to override that. So I will just hash the dfprint, and to change the index and to make sure the index starts at 1 and not 0, you just add this little line, which is possible via a NumPy formula. So this should be all done. We'll display the final data frame. And bingo, we've got Everything nicely presented, and we've got our index starting at 1. We're pretty much done. What we want to add as well to this code is a download button. So basically, if you want to download this data to this table into a CSV, you can do it. It's very easily done with the convertDF function, which converts the data frame to a CSV. And then we've got a function, native function in Streamlit, which allows you to download data, not just CSV. That could be images, that could be text, JSON, which is being called by st.downloadButton. And then you specify the CSV, the type of the file. So in this case, CSV, the label, which is the call to action on the button, and then the file name, classification results, which will be the downloaded file. So if I press download, you can see here, we should have our results on a CSV. That's it for the code. Let's switch back to the presentation. I'll show you how to deploy this application to Streamlit Cloud for free. So now that your app is working flawlessly on your local machine, what you want to do is share it with the world. And you can do it via deploying on the free Streamlit Community Cloud service. The only thing you need to do to get started is to head off to streamlit.io/cloud, create an account, and link your GitHub account to it. So you do need to have a GitHub account. And what you need to do is to upload all those files that we've created during this tutorial to a GitHub repo. Once that's done, I'm going to show you what it looks like. So this is my Streamlit Cloud account. As you can see, there's quite a bit of apps here. You need to click on New App. And here you'll have a screen with 3 fields, which will link to your repo setup. So all your repos will be displayed in this field. So I'm going to type 0 rather. And this will link to my repo. It will display the branch name and also the Python file path. Once that's done, you just click deploy. And I'm not going to do it here because it may take 1 minute or 2 and we haven't got the time. But once that's done, you will see your app displayed with your lovely zero-shot text classifier.streamlit app URL. That's it. The only thing I want to show you as well, guys, is the secrets field in your app. When it's deployed, you need to go into the settings section, go to secrets, and then the API key that we've pasted in the toml file earlier needs to be pasted in this section. So without this wouldn't work. So you need to paste that into the secrets manager. And off you go. I've repasted the links to the repo and to the app and the QR code if you wanted to play with it. Thank you very much.
Hello, we've got a breaking news alert. Now bear with me as we don't quite understand what's going on as of yet. Our Channel 8 News team is being bombarded by reports of what people are calling data superheroes. Here's what we know so far. Multiple individuals have been spotted all over the globe doing what can only be described as saving our data. We have this clip submitted to us by Felipe Hava, and it seems to show a figure flying in and doing something incredible to the old industrial mill on 53rd Avenue. That is simply amazing. Now joining us live on the scene is Elsa Mayer. Elsa, give us an idea of what's going on over there.
Thanks, Leif. I'm here downtown where moments ago, 2 individuals were spotted lifting, rising up alongside this building here. This is truly unbelievable. If it weren't for the footage captured by Daniel Myers, I wouldn't believe it myself. Leif, back to you.
Thanks, Elsa. Stay safe out there. Here now is some footage coming out of Amsterdam of what seems to be a person holding back a tsunami of data. I'm not sure what's even going on here. Adding to all of this, cities around the world are starting to see this symbol pop up. What does it mean? Who are these people? It looks like these data superheroes are somehow saving our data. I'm not sure what's going on, but I can tell you this. I'm sure glad they're on our side. For Channel 8 News, this is Leif de Rausche signing off.